Hey, ladies and gentlemen, welcome to 6-2. This is the second lesson for this year's work, because it's the new year and all. Interesting fact, did you know that you're part of the Burma Nation? It's part of Burma, which actually is the former country, or I think now is the country of Myanmar. So it's kind of an interesting fact. All of us Burmans, we basically made a country, so we're a pretty big deal. At least that's what my mom and dad told me very eloquently. All right, so we're talking about 6-2. It's systems of equations, solving them by using the substitution method. I would encourage you to follow these steps. Step 1 is to solve one of the equations for one variable, making it say x equals or y equals. The next one is to substitute that expression from the step 1 into the other equation, and then solve the equation for the other variable. Step 3 is to substitute what you found out for the x or for the y back into the equation to see what the other variable is either the x or the y. So we'll show you what those steps look like. I would encourage you to write these things down into your notes. All right, so let's get started with the first example here. You'll notice that one of our equations already says y equals, so step number 1 was to solve for it. It's already been taken care of for us. So we're going to plug this stuff in to the y because it says y equals to of the other equation. So we're going to say 2x plus the other stuff that we're substituting in, which is a negative 4x plus 12 in for y, and then it equals to that 2. So our job is to just solve this equation now. So you'll notice that we have these like terms of a 2x and a negative 4x, which is a negative 2x, and then that plus 12 just comes down, and now we can solve this. So we're going to solve by getting rid of that 12 by going to subtract 12 to both sides. And we get ourselves one of those beautiful negative 2x is equal to a negative 10. And after we get to that step, it's just us solving like we've been doing for many, many months now. And you guys kind of rock at this stuff. So then x is equal to a 5. So in my ordered pair answer, I have 5 for my x. Now my next step is to use the fact that we know that x is 5 and to choose one of these two equations to plug it back into. Now I think it might be easiest to plug it back into this one so that we already can figure out what y equals pretty easily. So let's do that. So we're going to say y is equal to a negative 4 times that 5 plus 12. Now notice all these steps that I'm actually showing instead of just fake showing it. That way we know we're doing things correctly. So a negative 4 times a 5 makes a negative 20, and a negative 20 plus this 12 is what our y is equal to, and that's a negative 8. So we have the ordered pair of 5, negative 8. So if we were to graph those things, these two equations are going to be at to the right 5, down 8, and that's going to be the spot where the two lines intersect. So all of your answers must be in an ordered pair form. All right, let's try it again. This is example number 2. We're going to solve one of these equations so that they say x equals or y equals. I'm going to make this one say x equals by moving this 2 to the other side. So I'm going to add 2 to both sides. So that's going to say x is equal to a 2y minus 3, because I did plus 2y to both sides. So now I have this stuff, the 2y minus 3, that I can substitute in for the x over here. So it's going to say 3 times that 2y minus 3 plus the 5y in the second equation. So we're just substituting this stuff in for the x. Yep, there's the x. And then equals to 24. So I'm going to have to distribute. That makes us have a 6y and a minus 9, because a 3 times this and a 3 times that, plus the 5y, and that equals to the same 24. So we got to combine our like terms. So as you guys have been doing with me here, maybe you're beating me done. That makes 11y's minus 9 is equal to a 24. Then we add 9 to both sides. You can see that these are going to take a little bit of time and some space. Ooh, I went too far. And then we are left with 11y's is equal to 33. So then we can do that divide by 11 to solve. Divide by 11 to solve. And y is equal to a 3. So in my ordered pair answer, we know that the y is 3, and that's the second number. So now that I know that y equals 3, I'm going to choose to plug it back into one of these equations. I'm going to choose to put it into this one because it would be much easier to figure out what x equals since we already have x by itself. So I'm plugging it back into this equation. So it's going to say a 3 is equal to, what was that, a 2y, I can't do that, I did that wrong. We're plugging it in to figure out what x equals, so I screwed that up. Don't tell your parents, they think I'm perfect, I was told. So x is equal to a 2 times that 3, and then minus 3. So 2 times 3 is 6, minus a 3 makes it a 3, so x is equal to a 3. Hey, that's kind of cool. We got x equals 3, y equals 3. And hopefully we just did that right. See, 2 times 3 is 6, minus 3 is 3. Yeah, perfect. So my ordered pair answer is this stuff. Now the really, really cool thing about these problems is that you can actually plug them back in to see that they are working. So if I plug in a 3 for x, so 3 minus a 2 times 3, so 3 minus 6 equals negative 3. That one worked. And we know that we're doing things correctly that way. Yeah! All right, let's do another one. All right, on this problem, same idea. We're going to get x or y by itself. I'm going to choose to bring the x over because I sometimes like having a y by itself. It looks more fun that way. So I'm going to go minus x minus x. So we're going to be left with a y is equal to a negative x minus 2. And I'm going to substitute this negative x minus 2 into the y. So that's going to go right over here. So it's going to say 2 times x plus 2 times, what did I just do there? That goofy looking. 2 times x, we don't need that weird line. And then we have the times the quantity of this negative x minus 2 and equal to 8. All right, our next step would then be to distribute. So we're at a negative 2x and a minus 4 from this math. And we can bring down the other things that we did not quite use. And we can combine our like terms here. So 0x's plus 4 plus 4. So 0x's equals to 12. Is that a true statement? I don't think so. We're going to get ourselves a no solution on this specific problem. Unless I screwed up someplace, which I don't think I did. All right, so that's our answer for this one, folks. I know that my face is in the way for this specific problem. So what we're going to do is we're going to use this problem as a problem that we're going to start class with tomorrow. So make sure you do your best. This says $35.25 for a yearly membership, $6.25 for a single admission. Do your best to come up with an answer for this, and then we're going to solve it tomorrow. So this is your chance to show that you actually, truly do know how to do this stuff. All right, folks. This is the Burma Nation, formerly of Myanmar, formerly of Burma, now Myanmar, and we're checking out.